Okay, so remember last time we talked a bunch about sentence forms. The difference between a particular sentence, which we represent with a big capital letter, versus a sentence form that we represent with a small lowercase letter. Right? And we talked a bunch about more complicated individual sentences like this matching more complicated forms. And now we're ready for the next step. So something with lowercase letters like that is a sentence form, because that's just one sentence on its own. Something like this is called an argument form. So just like a sentence form with lowercase letters, except we've got more than one sentence that are connected, or some of them are the premises, and one indicated by that 3 dot symbol is the conclusion. So that's the next thing we've got to learn about, is argument forms. And just like with particular sentences being instances of argument forms, particular arguments are going to be instances of argument forms. So these two premises right here match this form, right? Some argument forms are valid, and that means that if the premises are true, then the conclusion's got to be true. And some argument forms are invalid, where the conclusion might not be true. We're going to be especially interested for a while in finding the valid argument forms, the kinds of arguments that are guaranteed to get you to the truth if you at least started out with the truth. And all the inference rules on that one handout with like 8 inference rules are valid argument forms. And we're going to use those in our derivations to try to prove that particular arguments are valid.
Are those the only valid argument forms?
No. There are lots and lots of valid argument forms. There are lots and lots of valid arguments and lots of valid argument forms. We are eventually going to learn a complete set of, I think we're going to have 18 rules at the end. And once we get all the rules, here's what we'll be able to do. For any argument that's valid because of its form, we're going to be able to show that it's valid using those derivational rules. So any argument form that's actually valid, we'll be able to show that it's valid once we've got all 18 rules. And in that sense, the rules that we're going to learn are a complete set of rules, because any argument form that's valid, we can show that it's valid using those rules. Does that answer your question? Good. So we've only started out with 8 so far. So we'll spend a little more time working on those 8 rules, and then we'll get another set of 8, and then 2 more that are special by themselves at the end. And then once we have all 18 rules, then we'll be able to show that any valid argument form is in fact valid. Okay. So we've got a match between these 2 premises and the premises of this argument form. Does that make sense? You can see they look the same, right, on both sides. So, seeing this form and this conclusion that we're going to get to, which particular sentence should I write as a conclusion to match that form over there? Yeah, George.
Conclusion B.
Say it again.
Conclusion B.
Good. So you'll notice all our A's match to P's and all our B's matched to Q's. Yeah, good. So this particular argument is an instance of the valid argument form disjunctive syllogism. And the rule disjunctive syllogism works in a couple different ways. One is this form on the left where you got a disjunction and then the left side disjunct is negated. The other one over here, you got a disjunction and the right side disjunct is negated. And if you have an argument that looks like that, then you get to conclude that the left side disjunct must be true. So these are, subtly different forms, but they, the rule disjunctive syllogism we're going to allow to cover both forms. And it should, I think, make sense intuitively that if you've got a sentence that says this thing is true or this thing is true, and then a second sentence that says one of them is not true, then you get to conclude that the other one's not true. And it doesn't really matter which order they go in. If you switch the order, it doesn't change how the rule works. Another thing that doesn't matter when dealing with argument forms is the order of the premises. So here we've written the disjunction first and the negated disjunct afterwards, but it's still just as good of an argument if we've got not Q first, P or Q second, and P last. So we're dealing with this rule disjunctive syllogism. You can switch the order of the disjuncts, and that doesn't matter to whether you can use the rule. And you can also switch the order of the premises. That doesn't matter to whether you can use the rule. Okay. Now I want you to look at number 42. So the task in number 42 is to identify which of those particular arguments are instances of disjunctive syllogism, this argument form. Okay.
Pretty good.
Okay, Mayura, can you tell me, is this an instance of disjunctive syllogism?
Yeah,
Good, how'd you know?
because it's saying it's not C, so therefore it has to be A or B.
Good. Again, a surefire way to tell is if you can map particular sentences onto the variables. So our C is going to be P. What's our Q going to be?
A.
Just A or what's
A or B.
A or B? Good. So we want the whole rest of the disjunction. So that's going to be our Q. Our Q there as well. Good. It says is an instance of disjunctive syllogism. All right. Next one. Zach, is this an instance of disjunctive syllogism?
No,
You're right. How do you know?
because it's just saying like, but I just know it's not because there's, I guess the A is being used as one of the statements, but that's still true. And
Oh, good. So you're noting that we have A there and A there too, right? What would it have? What would have to be different about the A for it to work?
I think the A would have to be like not A.
Good. Because to have disjunctive syllogism, you have to have a disjunction and then one of the disjuncts negated.
Yeah.
And we don't have that. We just have a disjunction and then one of the disjuncts. Like, that's not an instance of disjunctive syllogism. It doesn't fit the right pattern unless there's a negation there. Good. Laura, is this an instance of disjunctive syllogism?
No,
You're right. How do you know?
because it would have to be different. I don't know. It has to.
Right.
So we've got a disjunction in our first premise. That fits the pattern, right? What would we have to have in the second premise?
There would have to be a parentheses around the A,
Good.
so then they can both be negated.
Good. We'd have to have A or B negated. Without the parentheses, what's the thing that's negated?
Just the A.
Just the A. So if we don't have the parentheses, then we don't have the first disjunct, A or B, negated. So we don't have the right pattern. Good. So you want to try this one?
I
that
don't think
an
I could do
instance
it.
Sorry,
I don't think I could do it.
Not sure. Okay. Yeah, Jordan, go for it.
I think that it is an instance of disjunctive syllogism because both A and B are negated.
Good. So we've got a disjunction with this thing and this thing, and then the negation negates all of the whole thing, A or
Because
B.
they're in parentheses.
Good. You're right. This one is an instance of disjunctive syllogism. It's a follow-up for you, Jordan. Is this an instance of the left kind or the right kind of disjunctive syllogism? Is it this kind or this kind? Oh, Jordan. Sorry, it's okay if you don't want to answer this one, but I just wondered if you know, is this number 4? Is that an instance of this kind of disjunctive syllogism on the left side or the kind on the right side?
Not sure.
Not sure?
No one.
Yeah.
The right one,
How do you know?
because A or B is Q.
Good.
Oh.
So the difference is that this one, the left side disjunct is the one that's negated, and this one it's the right side disjunct that's negated. The Q rather than the P. And this one is the right hand side. So you're right, it is that right side one. Good. Okay. Not A or not B. So not B. Alright, fair. Yeah, with this one. So we can talk it through, right?
Yeah. So I think it's
You think it's not an instance of
wait,
disjunctive?
no, I think it's true.
Think it is an instance of disjunctive syllogism. Okay, why do you think it's an instance of disjunctive syllogism? How did you know? How did you know it fits the pattern?
Well,
I'll tell you, you're right. You're right.
well, because it's either not A, not B, and not B pattern.
Good.
That
So let me put circles around the things that match. Maybe this is a strategy that might help to figure these ones out. So we've got, A is the same thing
And
right
there's
there and there,
B, B.
and then not B there. So notice on the right side, I circled the negations inside too, right? Because that's the sentence that's on the right side of the disjunction, the sentence that's right there. I didn't circle the negation there, and that's actually a good thing. Do you know why it's good that we have no negation there and we do have a negation there? It's because of the way this pattern works. That we want to have a disjunction, and then the part that matches, we want it to be negated on a line by itself. All right? That's what we want. Is we want a disjunction, and then one of the disjuncts negated on a line by itself. That exactly fits this pattern on the left. Is an example of disjunctive syllogism. Okay, number 6. Jake, is this an
Yeah.
example of disjunctive syllogism or not?
It's not.
Jake says not an example of disjunctive syllogism. Why?
Because it's just taking out not B, so it's still A or C.
Good.
But it's not taking out the entire phrase, so.
So,
Didn't you say that the parentheses don't matter?
so there's a sense in which parentheses matter and a sense in which they don't. And I mean, more carefully, parentheses matter for certain purposes, and for other purposes they don't. Sometimes they make a difference. So here's how parentheses make a difference. They make a difference to what sentence that is, to which things are being connected. Where they don't make a difference is to the truth value of what's being said. So switching the order of the parentheses, like say this, gives us a different sentence that we can make different inferences with. But it so happens that they have the same truth value. These things are equivalent. Let me try to give you an analogy from math. Maybe this helps, maybe it doesn't.
How are those? Okay.
So these are, I mean, not the same expression, but they're equivalent. They're equal, right? It's the same sort of thing that's going on here. These are not the same expression, but they're equivalent.
Oh, it's like,
Is it a rule that says, is this one actually a rule? Because it looks like it would work if you take out B, and then it's, because the answer technically works, but it's not
So,
syllogism.
we're not going to end up having a single rule that will validate this inference. But what you're getting at is that it makes sense that this would be a valid inference, right? That if you've got three options and you take out one of them, then the other two are left, right? And there's a way that we're going to be able to show that this inference is valid, but it's going to require other rules that we don't know yet.
Yeah, I'm saying, is there a rule that are, like,
So,
but it's not disjunctive syllogism for the point of this thing.
So, I'll show you very quickly how we would prove something like this, and we'll learn the rules later. So, first thing is we have to turn this into this, and there's a rule called commutativity that's just like a rule in algebra that tells you can switch those things. And then there's a rule called associativity that's, again, just like a rule in algebra that tells you can switch the order of those parentheses. And then this plus this matches this form to get to that. So you have to learn rules about associativity and commutativity before you can do that.
So you can switch them and then make it disjunctive syllogism.
Yes, it'll eventually be a disjunctive syllogism once we learn what are called equivalence rules. And commutativity and associativity are some of them. And there's some others that are analogs to things that you might have seen in algebra. So I mean that's an example of the point I was making to Nick's question. Does the order of parentheses matter? And the answer is it does matter to whether it's an example of disjunctive syllogism. It doesn't matter to whether the argument is ultimately valid. Because at the end of the day, this is a valid argument even though it's not an example of disjunctive syllogism, but we have to do some tricks using these equivalence rules to turn it into something that we can do a disjunctive syllogism with. So like, this argument's valid even though the parentheses are switched, so that's the way in which parentheses kind of don't matter. But they do matter to doing the proof, because then you have to use those other rules to show that it's valid.
What is the rule that states that even if the sentence states A or B or C, that we can still say A or C if B is negated?
There won't be a single rule that tells us that this is a valid inference. The way we'll do it is there'll be a DS step, and then there'll be a couple other steps using the rule called associativity and the rule called commutativity to kind of switch it around into the right form, which is A or C or B. And then notice this and this match that pattern there. So it will be a disjunctive syllogism. We have to do a couple steps to switch it into the right form to do a disjunctive syllogism. Okay, number 7 down here. Laura, do you want to help us with number 7?
Yeah, for number 7, I think it's not.
So you say not an instance of disjunctive
But
syllogism.
it might be, because, I don't know, does it need to be a double negative, or do the double negatives cancel each other out? And then it could be a
Because number
positive?
8 is what you just read.
So we do, in fact, need the two negations to do a DS. So you're right, it's not an example of disjunctive syllogism.
Then how is 5 an example of disjunctive syllogism?
I think we're doing 8 right now, actually.
We're doing 7, that's just 7, it should be what 8 is.
Yeah, so 8 actually looks like this. 7 does not have those negations
Yeah.
on it.
Yeah.
And with no negations, it's not an example of disjunctive syllogism. And the reason is that we need this thing negated to do disjunctive syllogism.
But how is 5?
So 5 is because we've got
Oh, yeah, you just
A.
flip it, so it'd be A or not
negated.
B and then not A.
Yeah.
Okay.
Yeah. So it's not an example of disjunctive syllogism without the negations. So I mean, I'm kind of sneaking in stuff that we'll get to later that are called equivalence rules that tell you when things are equivalent. And associativity and commutativity are a couple. Another one is called double negation, and that tells you something double negated is equivalent to the thing with no negations. And that's the rule that lets you just add and take away two negations at a time.
But like, they can't cancel each other out?
So I mean, they cancel out in the sense that not P and P are equivalent.
Yeah.
Those things are equivalent.
Like, you're just trying to get the most exact, I guess?
Yeah, you have to explain it.
So, I mean, one way of thinking about it is you got to go through every step one at a time. And one of the steps is converting from this to this, or this to this, so that you can use the rule. And we have to do that because the rule DS only works with one premise that's negated. So you have to have something negated. So if you're starting out with something like A, then you have to do a step to add two negations before you can do a DS. Okay, so then this one, what I had written for number 7 is in fact number 8 with the two negations. And we've already sort of gone over this. This is an example of DS because we've got not A negated on line 2. Are you up for this one?
Mm-hmm.
Is this an example of DS or not?
No.
No. How do you know?
It's the same as 6 where you're taking it out of the parentheses.
Good. You can't just take something out from the inside. It would have to be this whole thing negated to do a DS. Excellent. All right, Jake, number 10.
Yes.
Let me write the whole thing on the board first and then tell us about it.
We just did it.
It's the same as 6, for why it didn't work.
Okay, so you said Yes, this is an example
Yeah.
of DS,
And it's the left one.
and it's
No, it's the right one.
the right one, because we've got the C here. It's matching on both sides, getting negated on the second premise, and then we also get the left disjunct and the conclusion. Good. So that one is an example of DS as well. Okay, one more on the sheet. Nick. Is this last one, number 11, an instance of DS or not?
Yes,
You're right. How do you know?
because it is the equivalent of the right side over there, just reworked to say not Q before P.
So you think it's okay to have the negated premise first?
Yeah.
Yeah, you're right. It is okay. It's okay to have the negated premise first. The order of the premises doesn't matter for this rule, and actually for any other argument form or rule that we use. The order of the premises doesn't make a difference. All right, good. So that was number 42. How was that? People feel okay about getting when we've got an instance of DS or not? All right.
We're done with all this yet.
That-
How many have we?
Okay.
Oh, 20 more left.
So I got some time. That went pretty quick through number 42. Good. I want to jump to number 44 now. I've got a bunch of copies. I don't know if anybody has copies of 44
I
yet.
have.
I do.
A couple people do. Okay.
I do not.
Jeez.
Okay.
No, you weren't.
Does everybody have a 44 now? Good. All right, it's gonna take me a minute to like erase all this stuff. There's some space.
It's kind of weird. You have to use it on an angle.
Um,
It keeps turning.
So for this one, you're gonna have to use 4 different rules. DS is one of them. MP is one of them. Does that rule sound familiar? Remember that? It's been a while since we've done MP.
Modus ponens.
Most times.
Modus ponens. And then you're gonna have to use MT too. I think we talked a little bit about MT. So here's the MP rule, just so we've got it written down. P horseshoe Q, P, so Q. The MT rule is P horseshoe Q, not Q, so not P. And both of these rules have just the one pattern. There isn't like a left side and a right side version for these ones. Have to be in exactly this form. Again, you can switch the order of the premises, that doesn't matter, but it does have to be the right-hand side that's negated for MT and the left-hand side that's asserted for MP. And then the rule simp. I believe we talked about it a little bit before. That rule says if you have a conjunction where you say this thing and this thing, then you know that the first thing's true and you can infer that on a line by itself, and you know that the second thing's true, you can infer that on a line by itself. So for example, if I told you Jordan and Zach are both students in this class, then I get to infer Jordan's a student in the class and Zach's a student in the class. Each one of these, I know that they're both true. Okay. So those are the rules that we're going to use for these derivations.
You too. Never sneezed.
I get into the room, but like, it was really loud outside. Me too still.
Okay, so the problem we're given is we're given these two premises and told we have to prove this conclusion from those two premises using just those rules. Laura, you want to start us off?
What are we supposed to do? We're just supposed
So
to.
you're supposed to get to A. That's your goal, is
Yeah.
to get to A from these things using those rules. So does 1 and 2 look like any of those patterns? Maida's got it. Tell us, Maida.
Is disjunctive syllogism?
Yeah, good. So
I haven't
It's-
written everything down yet.
a disjunctive syllogism. That's right. And what does disjunctive syllogism get us to in the next step? Like if you start with something like, I think it's the right-hand side, right? You start with something like that, and then have something like that. What should go next?
Therefore, A.
Yeah, A goes next. So A is what we get on line 3. And then to justify how you know that A is true now, we'll write line 1 and 2 and the rule ds. So that's how we got it to line 3 was knowing that this is true and this is true, and use the rule ds to put those together to get to A. Okay, so that's a proof of A from these premises. So that's how we do number 1. All right, I'll write number 2 up, and we'll go through that one as well. Okay, so our goal is to get to C. That's our goal, is to write C on one of these lines in a way that it follows from these lines using just those rules. This time we're not going to be able to get to C immediately, but there's at least one thing we can do already with the lines we've got. Jake?
Simplification.
Simplification. Okay, so what should I write on line 3?
A, 1 sim,
Good?
B, 1 sim.
So I'm going to simplify out both parts. In this case, actually, I'm not going to need both parts, but there's no harm in simplifying out both parts. That's right. That's correct to do that. Okay. Now I actually do have enough pieces to get to C. So I'll tell you that part. I'm going to be able to write C on the next line. Now our question is, which rule and which lines let me get to C from stuff I already have? I bet Jake does know the answer, but I want to see if somebody else knows. Yeah, Jordan. Good, yeah. So I use the rule modus ponens. It says I get to the consequent of a conditional if I've got a conditional and the antecedent on lines by themselves. Which lines did you use with that rule MP to get to C?
All of them.
All of them? Did you use line 3? Did you need line 3 to get to C? Here, let's start from the other direction.
Ridiculous.
I think you're right, we didn't need it. We definitely 100% needed line 2, right? Because that was the only place that C was anywhere at all before. There's one other line that matched the MP pattern to get us to C. So if we look at that MP, 4, good. Right, exactly right, good. So we need 2, 4, and MP. And the way we can tell is sort of matching up the individual sentences to the forms, right? We know C is our Q, and B had to be our P because B is the antecedent of this one, right? So then we looked for the P again somewhere else. And that's how we did it. Nice job. Okay, so that's it for number 2. We got to our goal, and once you get to your goal, the thing after the 3 dot symbol, then you're done with the derivation. So when you're given a problem like this, I think a good way to think about it is that the premises you're given are your starting points, and the conclusion you're trying to reach is your finish line. When you get there, you're done.
What does MT stand for?
Modus tollens. So MP and MT, you might notice they're kind of similar, right? They each start with a conditional. And the names that we use for them today come from Latin. MP means the mode of putting, and MT means the mode of taking. And I don't know if that really makes sense. I mean, the way it makes sense to me is for MP, you put forward the antecedent of the conditional, and for MT, you take away the consequent of the conditional by negating it.
So you can only negate the consequent. You can't say that, oh, Q is right, so therefore P is also right.
Yeah, so let me write these up too. So you're talking about this form, right? So these are both invalid forms. They have names. This one is called Asserting the Consequent, because it's the second premise asserts the consequent of the conditional. This one's called Denying the Antecedent, and they're both fallacies. Neither of them is a good inference. They will both lead you astray. So these are the good ones, these are the bad ones. Don't use those.
Why?
Because there are instances of them where the premises are going to be true and the conclusion is false. Let me think for a second to give you a good example. Okay. All right. It's a joke. Nobody get offended by my example.
Is this going to be racially insensitive or gender
No.
It's gonna be a
insensitive?
stupid joke.
It's gonna be about
Are we going to hear the
Jake
N-word?
is really dumb.
No.
Therefore, Laura is smarter.
If there are 3 genders,
I don't get this.
then Australia is in the North
I
Hemisphere.
don't get what the conditional means. Yes. I don't get what it's supposed to represent.
Okay, here's an example of asserting the consequent. So,
Oh.
claim 1, if Steve's abandoning his baby, if Steve's abandoning his baby, he's not home. That's true, right? Because like I can't, like the baby's at home. I can't like abandon her if I'm still there.
I mean, well.
So that's true. And it's also true that Steve's not at home. But it would be absurd to conclude from that Steve's abandoning his baby, right?
Baby's with him.
And that's this pattern.
Nobody said the baby was home.
What about the baby's
What if
mom's
he's,
parents?
what if the
That's this
baby-
pattern.
What if the baby's
So I mean that should give you a flavor of why that's not a good
The
inference.
baby's already-
Because both of these things are true, but it's not true that Steve's a baby.
Nothing.
Okay. So back to this problem. So again, our goal is to get to C using these, from these starting points, using those rules that we've got. Zach, start us off here. So a good way to start is think about, is there anything you see here that fits one of these patterns, that looks like one of those argument forms?
Well, kind of.
Kind of.
I mean,
Which argument form do you see it at least close to?
probably disjunctive syllogism.
Okay, so we've got DS with line 3, right?
Yeah.
Okay. What would we need to do a DS with line 3 to have it be exactly?
Well, is that a conjunction or a negation in front of the C?
This is a disjunction
Oh,
right
okay.
there.
Disjunction. Okay. Well,
Isn't that applying to intercross?
actually, I don't know. I thought that would be the pattern of DS.
So this will, but it's only one of the lines, right? Like we've only got the first part of the DS.
Oh,
Alright,
okay.
'cause
So I'm asking, what second part do we need
Oh.
to do a DS?
To complete it?
Yeah, yeah.
There's the,
Here's this.
Well, I get that, but I'm just like.
therefore.